Training a deep learning model, specifically a deep neural network, DNN, involves several steps. Here's a general overview of the process. Pradeep K. Suri. Author and researcher. 1. Data collection and pre-processing. Gather a representative and diverse dataset that accurately reflects the problem you're trying to solve. Clean the data by removing duplicates, handling missing values, and performing any necessary transformations. Split the data into training, validation, and testing sets. 2. Architecture design. Choose the architecture of your DNN. This includes deciding the number of layers, the number of neurons in each layer, and the type of layers, dense, convolutional, recurrent, etc. Consider using established architectures like CNNs, convolutional neural networks, for image data, and RNNs, recurrent neural networks, for sequential data. 3. Initialization. Initialize the model's weights. Common techniques include random initialization or using pre-trained weights from a similar model. 4. Model compilation. Select a loss function appropriate for your task, example mean squared error for regression, categorical cross entropy for classification. Choose an optimizer, example ADAM, SGD, to update the model's weights during training. Optionally, include additional metrics for monitoring during training, example accuracy, precision, recall. 5. Training. Feed the training data through the network and calculate the loss. Backpropagate the loss to adjust the weights using the chosen optimizer. Repeat this process for multiple epochs, complete passes through the training data, while monitoring the loss on the validation set. Implement techniques like learning rate scheduling and early stopping to improve convergence and prevent overfitting. 6. Validation and hyperparameter tuning. Monitor the model's performance on the validation set. Adjust hyperparameters, example learning rate, batch size, based on validation performance. Experiment with different architectures and hyperparameters to find the best combination. 7. Testing. Once training is complete, evaluate your model's performance on the testing set, which it has never seen before. This gives you an estimate of how well the model will perform in real-world scenarios. 8. Fine-tuning and deployment. If the model's performance is satisfactory, you can consider deploying it for real-world use. Fine-tune the model on new data as it becomes available to adapt to changes in the data distribution over time. 9. Regularization techniques. Implement techniques like dropout, batch normalization, and L2 regularization to prevent overfitting and enhance the model's generalization capabilities. 10. Interpretability and visualization. Use visualization techniques to understand what the model is learning, such as feature visualization or activation visualization. Remember that deep learning can be complex, and success often comes through a combination of experimentation, domain knowledge, and understanding of the data. It's also important to stay updated with the latest research and advancements in the field to continually improve your models. Thank you.